Hi guys, welcome back to my channel Pirai Academy. In this video, we are going to see about a Leetcode question number 198 and also 213. Okay, so house robber 1 and house robber 2. If you know about the house robber 1, then you can easily just crack the house robber 2. That's the reason why I just combined these two and made into one video. Okay, so you are a professional robber planning to rob houses along the street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken into a same night. Okay, given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. Okay, so for example, if this is a nums, this is the given array, then I'll be taking this 1 and then 3, leaving this 2 aside. Okay, so that it will be giving me the maximum amount called 4. You can also try all other possibilities, like I will be taking this one and the last one only 2. I'll be taking this one, and okay, if I take this 2 and then 1, then it will be only 3. So what is the best possible answer? It is 4. That's the reason why I'm returning 4. Okay, so when I saw this problem, the first thing that comes into our mind is greedy, because they are asking us to find the maximum. Okay, so immediately we will be going for the greedy approach. So what is the greedy approach? Okay, stand at the index number 0 and take all the even index elements, or stand at the odd index element and take all the odd index elements. Like I will be standing here. Okay, then I'll be taking this 2, 9 and 1, so which is equal to what? 12, right? Otherwise stand at the odd index element or the alternate elements, which means 7 and 3. If I take these two, it will be 10. So what is going to be my answer? It is 12. This is how we will be doing the greedy approach, right? The maximum answer. But it will be failing at some particular case, like 2 comma 1 comma 1 comma 2. Okay, so see here in this array, if I do the same thing, if I take 2 and then 1, okay, again I'll be taking this 1 and 2, which the maximum will be 3 only. But if I take this 2 and the last 2, then 2 plus 2 is equal to 4. 4 is the maximum amount. So here the greedy fails, right? So now we are getting into a recursion. So always remember this: whenever the greedy fails, we want to do all possible combinations and take the best. So that's going to be done by the recursion. Okay, so this is the example that failing in the greedy, right? So this is the example that should be passing in my recursion. So let us discuss about it. So for the recursion, first of all, I want to design the parameters. So what are the variable parameters that I am going to have in the recursion function? So I'll be telling you index should be included, because everything are in an index, right? Everything have the index, and we want the index to traverse also. That's the reason I am taking the index. So 0, 1, 2, 3. So this index. So other than that, we don't want anything. Okay, so listen this. First of all, where I should start? I will be starting from the last index. Okay, now from this last index, I have two choice. Either take me and move to my previous index, or don't take me and move to the previous index. Can you understand this? What is the constraint they have given in the question? They have given that if you rob one house, just rob its next house. Okay, if you don't rob this house, then you will be absolutely robbing its next house, right? Can you understand this? So the same logic is applied in the recursion also. So for this f of 3, I have two choice. One is rob, another one is not rob or don't rob. Okay, not. Okay, now if I rob it, it will be like 2 is the amount I got after robbing it, right? Plus I'll be moving towards f of 1. If I don't rob, I'll be moving to f of 2. Simple. Now in next, so f of 1 also have two choice. One is rob and don't rob. If I rob it, it will be 1 plus go to f of minus 1. If we don't rob it, it will be f of 0. Okay, similarly for here also we have two choice, rob and not rob. If I rob it, it will be 1 plus f of 1. If I don't drop it, it will be f of 0. Okay. Similarly, again, here it is f of minus 1. Whenever our int is beyond our limit, then I'll be returning what? 0. Then I'll be returning what? 0. So it will be returning 0. So 1 plus 0 will be 1. So here the return value, here it is returning is 1. Okay. Now let us finish the rest of them. Here it is f of 0. When I reach f of 0, which means I'll be only having one condition. Take it. If you don't take now, then you don't take anywhere in the future, right? So take it. If I take it, what is the value here? F of 1 is 2. Sorry, f of 0 is 2. So it will be returning 2. Okay. So in my left side, it is returning 1, and in my right side, it is returning 2. I want to take the maximum. So what is the maximum? Maximum is 2. So here f of 1 will be 2. Now 2 plus 2 is 4. Now this function will be returning 4. That's it. Okay. Now let us go and finish the rest of the function calls. So f of 1 can have two choices. One is rob, another one is not rob. So in rob, it will be like 1 plus f of 0. If I don't rob, it will be only f of 0. Yes. Okay. Now for f of 0, it will be returning what? It will be returning 2. Okay. Similarly, here also it will be 2. 1 plus 2 will be 3. So here it will be returning 3. Here is this only f of 2, which means it will be returning 2. 2 or 3, which is maximum. 3 is maximum. So take 3. Oh, sorry. I done a mistake. Sorry, I didn't saw that also. So here, if I rob it, I want to go to minus 1, right? Sorry, minus 1. Minus 1 means it will be 0. This will be 0. So 1 plus 0, which is equal to 1. Okay. Here f of 0 is 2. So it will be returning 2. So which is maximum? 2 is maximum. So this will be replaced as 2. 1 plus 2 will be 3. Okay. Similarly, f of 0 will be returning me 2. Can you understand this? Will be returning me 2. Now what is the maximum among them? It is 3. Okay. Just return 3. So from my left side is 4. From my right side is 3. So whichever I will be taking, 4 I will be taking, because it is a maximum. 4. So 4 is the maximum, and it is going to be the result and output also. Now hope you understand how our recursion function is designed. Okay, if you don't know about the recursion, don't worry, I'll be giving you the playlist for understanding the recursion tree, recursion stack, and how the recursion works, kind of DFS approach. Just go and watch that video, then come back. I'll be giving that in the description. Okay, fine. So this is what the entire recursion will be. Now tell me what is the time complexity? So time complexity will be over 2 power n, and space complexity will be over n because of the recursion stack. Okay, and also it is 2 power n because for each and every recursion we have two choices. So for n recursion it will be 2 power n. Yes, so that's the reason why we are getting this time and space complexity. Now let us see the code, then we can go for the further things. So see here, here's a Java code. If you want the C++ or Python code, just search in the description. Fine. So see here, first of all, I'll be taking the length and storing in n, and I will be just returning the function call of n-1 comma. So here it is unnecessary. Just a minute, I'll be altering the code. Here it is unnecessary. Here it is unnecessary. Here. That's it. Okay. Now, and also I will be just passing the parameter as nums, but here the only variable parameter is this n-1. Okay. So here is the function. So inside that function, if my index is equal to 0, then I want to return that particular index value. If my index is less than 0, then I want to return 0. That's it. So these are the base conditions I have. Okay. And then there are two choices. One is pick it. Another one is don't pick it. Rob or don't rob. Okay. Fine. Now, if I don't rob, then I will be obviously going to index -1. If I rob, I will be taking that amount plus I will be going to previous, my int is minus 2. Okay, at last I'll be returning the maximum among them. That's it. Fine. So this is going to be your recursion code. Now, because of its time complexity, it will not be running and it will not be submitted successfully. Okay, we will be getting the time complexity error. So to avoid that, we are next going for another approach called memoization. Okay. Number 2, memoization. So memoization is nothing but like we will be storing something in our memory so that when it is again occurring at that particular time, we will be just taking the value that is stored and returning that value. Okay, by doing this, you can optimize your code. Like for example, see here is f of 1, right? Here is f of 1. Again, this f of 1 is occurring here also, right? In both cases, what is the f of 1 value? Here also it is 2, here also 2. Then why should I go down again for this f of 1 to find out what is its value? Can you understand this? Because of this only, our time complexity is of what? 2 power n. If I don't repeat this particular process, then my time complexity will be of what? O of n. Can you understand this? So my core logic here is I don't want to repeat same recursion call which is done before me, which is computed before me. Okay, for that, listen this carefully. This is my code, right? I'll be teaching you how to convert this code into a memoization code. It is so simple. Okay, we can do this using hash map, which is very much easier, or else we will be doing with array with n dimension. That's going to be dependent on the varying parameter. Okay, mostly I recommend you to learn about the array. Okay, because it will be leading you to do some other further optimization. Okay, if you want to do this hash map approach, learn about this array approach, and then you can be able to do the hash map approach. Okay, fine, I am sure about that. Okay, now let us begin. First of all, you want to design the particular array. Okay, for an array, I want to decide how many dimensions I should have. See here, how many varying parameter I have? I have only one varying parameter, which means my array is going to be 1D array. Okay, and then let us take the same example we have encountered before. So this is the example, right? So what is the size of this array? It is 4. Okay, similarly, what are all the values we may encounter here for the variable index? So my index can be from 0. Up to n minus 1, which means my index will be from 0 up to n minus 1, which means my array will be of n size. My array is of n size. Okay, so n size means it will be 4, 1, 2, and 3. That's it. Okay, now the next doubt that comes into our mind is what should be the values to be initialized here. Whatsoever value you can initialize inside this, but it should not be returned by any function calls. So see here are some values that are returned, right? 0, 1, 2, all the positive values, and also 0. So better to have either null, or you may have -1, or you may have -2 or -3. Any negative numbers are null. I'll be mentioning like -1 for simplicity. Okay, now understand this. Here in the base condition, I want to add one line. Okay, what is that line is? If so, take for example, this is dp array. Okay, if dp of particular index is not equal to -1, then it is already computed. In this particular case, then return dp of index. That's it. Okay, at last also at this particular point, write one more line like dp of that particular index is equal to my result. What is my result? Max of pick and not pick. Okay, and then return dp of index. That's it. So this is going to be your whole modification to make your recursion code into a memorization code. Okay, now tell me what is the time complexity. It will be O of n, and space complexity will be O of n, and the space complexity is of two types. One is because of the array you have used, this auxiliary array, and another one is because of the recursion stack. Hope you understand up to this. Okay, fine. So let us see the code for this, then let us get into the next approach. Okay, so let me comment this. So here this is going to the memorization code. So first of all, I am just constructed a DP array and filled everything as -1. You may have -2, -3 or null, that's your wish. Okay, here I have mentioned like -1 because -1 is also not occurred in any one of the part. Like there won't be any function that will be returning -1. That's the reason I just initialize by -1. Now here's the function. So in this recursion function, I just modified one line, which I mentioned in the drawing explanation, and also here. That's it. So it is quite easy, right? So this is going to be your overall memorization code. Now let us get into the next optimization technique called tabulation. So why we are going to the tabulation? Because here the space complexity is occurring because of two things. One is recursion stack and array. First step is to avoid this recursion. If I want to avoid this recursion, I want to go for or while loop, any one of the loop, right? So I'll be converting my code into a looping code. Okay, so that's going to be next approach. So it is 2, right? Now it is 3. The third approach is, or the third step of optimization is tabulation. So this is going to be a bit difficult to understand, but still hope just see this video up to see this approach, this tabulation approach 1 or 2 times, so that you can understand this clearly. Okay, now for this tabulation there are some few steps to follow. The first one is, if my function is from n-1 to 0, then now in my tabulation it will be 0 to n-1. It should be in reverse fashion. If my recursion is top down, now I want to do from bottom up, and vice versa. Okay, so this is going to be your tabulation. Fine. Now the first step in your tabulation is, let me paste it. Okay, now the first step in tabulation is you want to alter your array. So now the array is initially like, we put 1 2 3. So for the input 2, 1, 2. Okay, now here it will be -1, -1, -1, -1, 0, 1, 2, 3. So this is how the array looks like. Now hats off now. Okay, in tabulation we want to focus on base condition. What are the two main base conditions? One is, if index is equal to 0, then there should be nums of 0. So same thing applied here also. Here in index number 0, just to put this index number 0 value, so it's equal to 2. So modify 2 here. So this is going to be your first step. Okay, then the second step is, index is less than 0, which means return 0. So here we only occurring of what? -1. Can understand this? So if I have f of 1, in this scenario only I will be occurring of f of -1. If I have in f of 0, then almost it will be written there itself. So that's the reason why we want to also have another value to store this f of -1. So I will be just creating another value, and here it will be -1, and here I will be putting 0. Whether it is valid? No. So I will be just changing this slightly different, like 0 to -1, -1, and -1, and make this index as 0, 1, 2, 3, 4. Okay, so I just alter the indices. That's it. Okay, now what is the next step? The next step is, see the body of the function. So these are the body of the functions, right? Sorry, these 4 lines. So these are the body of the functions, right? Okay, and ignore this line. Always ignore this line. Okay, now from here just start the for loop. So so index will be from where? Will be starting from 2, because see here here I'll be starting from n minus 1 up to what? Up to 0, which means up to 1. So it will be n minus 1 up to 1. Meanwhile, in recursion, it will be like 1 to n minus 1. But here we have shifted all the indices by one value, right? So you want to start from index 2 up to n. Can you understand this? Because the length of the array is 4, which means you want to start from n up to 4, which means n. Can you understand why I am putting the for loop like this? Okay. Now inside that, first take this line. So what is this line? Not pick is equal to, here it is a function call, right? It is a function call. Whenever there occurs a function call, just write like dp of, here it is index minus 1. So it is the only varying parameter, right? So write that inside of the bracket. That's it. Now pick is equal to nums of index, right? Nums of index. But here we are just altered our indices like this, okay? Which means this 2 represent index number 1, this 3 represent index number 2, this 4 represent index number 3. So which is equal to index minus 1 plus dp of index minus 2. That's it. Okay. And then last line, dp of index is equal to maximum among n and p. That's it. Okay. At last, what should I return? So see here, what I am returning here, I am returning n minus 1. Here I have added one index extra. So n minus 1 plus 1 is equal to n. So return dp of n. In other terms, I will be telling like, hey, just return the last index value. So here the last index is index number 4. Okay. So this is going to be a tabulation code. Can you understand this? So always remember, do this with a careful step, with more carefully. Okay, because here you can make as much number of mistakes. Okay, while explaining, I done a mistake. That's the reason why I just cutted those things, and then again I am resuming this video. Okay, that's the reason why I am telling you. It will be like if you don't have enough attention while converting the memorization into tabulation, you will be having some error in your code. Okay. Now what is the time complexity? It will be O of n. And what is space complexity? It is also O of n, because we are using an auxiliary array, but there is no recursion stack, so that O of n is eliminated. Okay. Now let's see the code so that it will be more clear. See here, this is the code. So at first I will be taking n as the nums length, and then if n is equal to 1, I want to return nums of 0, which means there is only one house. Then I will be returning that house. That's it. Okay. Now else I will be taking dp is equal to new int of n plus 1. Now dp of 1 is equal to nums of 0, and dp of 0 is equal to 0. Okay. Now I will be starting from index number 2. I will be reaching up to n, and then inside that loop I want to do like what? If I don't want to pick, I will be taking the next element. I will be going to the next index. Same thing I have written in the drawing explanation, right? Else in pick part, I will be picking the nums of index minus 1, and I will be going the previous index. Okay. Now in my dp of index, I will be just storing the maximum among them. At last I will be returning the dp of n. If I submit it, sorry, just a minute, I just comment this. Okay. Yes. So let me submit this. Yes, it is submitted successfully. Okay. Now the next step is going to the space optimization. So why we need a space optimization? See here we are using the entire array. Now we are just going to check whether we need entire array or we need just a small part of it. Okay, like that. So the next step, space optimization. Okay. So listen this carefully. In space optimization, the same code will be just slightly modified, like see here, this line, particularly this line. Here we are just taking what? DP of index. Okay. Here we want DP of index minus 1. Okay. Here we need DP of index minus 2. So I can tell you that if index is equal to 3, then I only need 1 comma 2. If index is equal to 5, then I only need 4 comma 3. Apart from this, I don't need any other indices. So I can tell you that we only need three part. Okay. So in easily we can say that I only need 2 in this. Okay, 0 and 1 as an array, DP array, and in my current I'll be storing its result. Can you understand this? Okay. So how I am going to construct it? So initially I'll be just writing this everything up to this line, Okay. So up to this line, then DP is equal to 2 parts, 0 and 1, and this 0 will be 0, and the first in this will be nums of 0. For example, if the nums is 2 comma 1 comma 1 comma 2, then I'll be just telling like 2 here. I'll be writing 2 here. Okay. Now the next step is write a for loop. For index will be from 2 up to n. Inside this, not pick is equal to DP of index is minus 1, index minus 1, which means it refers to the 1. So DP of 1, and in my pick it will be like nums of index minus 1. So here you can easily write like, instead of going from 2 to n, also you can also go from 1 to n minus 1 also. That's your wish. Because we have a DP array of only size 2. That's the reason why I'm going like this. Okay. Now here we can also eliminate this. So index plus DP of 0. That's it. Now at last in my current pointer, I'll be taking the maximum among them. So current is equal to maximum among the not pick and the pick. Okay. Now I need to update it like DP of 0 is equal to DP of 1. Just swap. Okay. Now DP of 1 is equal to current. Okay. At last, after finishing this loop, I'll be returning DP of 1. That's it. So this is going to be your entire space optimization code, and my time complexity will be O of n and space complexity will be O of 1. That's it. Because I haven't used any other auxiliary space, I only use the space of 2. You can also do this using a variable also. That I'll be showing in the code. Okay. As of now, if you clear with this, we can move into the code. Okay. So see here, this is going to be the code. Just a minute, I'll be commenting this out. Now this is going to be the space optimization code. So here the same code I written, the slight modification is here I have taken pre and previous 2. So pre is nums of 0 and previous 2 is equal to 0. Now I'll be starting from 1 up to n minus 1, and then I'll be taking not pick as pre. Just compare with my drawing explanation, that array. There I have written here like what? DP of 1, right? So that's going to be here previous. Meanwhile, in pick it will be nums of index plus previous 2, which means DP of 0. You can either do like I have mentioned in the drawing explanation, or you can do like this also. There I have used an array of 2 size. Here I have used 2 variables. That's your wish. Okay. Now at last, in current I'll be taking the maximum of them, and then I am just swapping all the elements for the next iteration. I am readying all the variables for the next iteration, like previous 2 is equal to previous, and previous will be equal to current. Now at last I'll be returning the previous. There I am returning what? DP of 1, the last element. Here I am returning the last updated value previous. Also you can return like current if you initialize current at first, here something like here. Okay. So this is going to be the entire code for the house robber 1. Let me submit it. Yes, it is submitted successfully. Now let us get to the house robber 2. Here the only difference is, see here, all the house at this place are arranged in a circle. Which means for example 1, 2, 3 and 4, then it will be like this. So 2 comma 1 comma 1 comma 2. Here I can take this 2 and then this 2, right? Here in house number 2 we cannot take these two things. If I take these two things, it will be adjacent. These two houses will be adjacent and it will be calling the police. Can you understand this? So I cannot take it. Now hope you understand what is the simple change they have made in the house number 1 and house number 2. So here how we are supposed to do this? See here, same thing. Whatsoever you have done in the house number 1, you are going to do the same thing here also, but the only difference is, for example, if you having let me take the big example so that it will be more useful. So let me take this example. Just a minute. So let us take this example. Okay, now see here in this example I can tell you that I will be first taking right here. In this example I will be first taking this 2. Okay, I can go up to what? I can go up to this 3. I cannot take the 1, right? So I'll be taking only 2 comma 7 comma 9 comma 3. Okay, or else I can take from this 7 up to this 1. Okay, whatsoever giving me the maximum amount after doing the house number 1 on this and house number 1 on this will be my answer. Can I understand this? They have clearly stated that it is in a circular manner. The houses are arranged in a circular manner. So I'll be taking either the first one and eliminating the last house, or I'll be taking the last house, eliminating the first house, and doing the separate house number 1 on the first thing and house number 1 in the second thing, and taking the maximum among them will leads to the answer as house number 2. Can I understand this? So for this, I don't want you to understand. I don't want to give the logic behind it. Just see the code. Everything is similar. See here, everything is similar. Okay. The only difference is, just see here. Case 1. In case 1, I will be having from 0 up to n minus 1. In case 2, I will be having 1 up to n. Other than that, everything will be similar. Here everything is similar. Here also everything is similar. So just try this by yourself. Okay, and comment below if you have any doubts. Just comment below, because I want you to understand how the house number 1 can be converted into house number 2. Okay, just do by yourself and give me the feedback about this 2 problems. Okay, because I just done this video very hurriedly. That's the reason I want your feedback about whether it is clear for you or not clear, or whether you have any suggestion for making the better video. Okay, and that's it. So if you want to know about these kinds of algorithms, just go and search in my YouTube channel. And if you really like this video, subscribe to my channel, and don't skip any videos in the DP series, because all the videos will be helpful once you are going for a competitive programming. Okay, and if you have any doubts, please make sure just comment below. I'll be just commenting the answers. Thank you.